today's kind of our algebra review. So 2-3 deals with parallel and perpendicular lines. Okay, how many remember what parallel lines are? Everyone have a picture of them? Okay, picture of perpendicular lines. Okay, we're going to relate them to your equations today. Okay, so first thing we need to do is we need to review slopes. So positive, negative, 0, and undefined slopes. Hopefully you were able to kind of use this as your reference out of your book there. A positive slope. If you're reading slope, you read it from left to right. So a positive slope increases from left to right. It's like a book. Whereas like a negative slope decreases from left to right. Okay, so it's like reading a book. A 0 slope is a flat horizontal line, whereas undefined slope is a slope like a vertical line. They can't ride a bike on it, right? You'd fall down and you'd be down here just splat. All right, that'd be you. Okay. So that's your slope. Hopefully, once again, a quick review. Positive, negative, 0, and undefined. A couple things. First, a positive number. We all know what a positive number looks like. We all know what a negative number looks like. But a 0 slope, when you're talking about a fraction, remember, slope means rise over run. So we could easily write a fraction that's positive. We could easily write a fraction that's negative. But when you're dealing with a fraction that's 0 or a fraction that's undefined, they have the number 0 in them. Both of them have 0. Does anyone know where 0 is in your fraction when it's a 0 slope? You have 50-50 chance, right? How many think it's like if this is my fraction, how many think 0's above the bar? How many think 0's under the bar? So how many think 0's over the bar? How many think it's under the bar? Okay, if it's a 0 slope, a 0 slope has a 0 over the bar. It's 0 over some number. Whereas if it's undefined, your 0 is under the bar. It's 0 or it's some number over 0. Now what I like to do is I like to think of if 0 is under the bar, it's undefined. If 0 is over the bar, the answer is 0. Okay? Try to remember those little tricks to help you figure that out. You're going to use that a lot in advanced algebra. You'll use it this year a bit. I see about 90% of the class really focused in, writing things down. I see the other 10% zoning out. They're like, whatever, man. I mean, dude, I learned this in algebra. I still don't know it, but that's okay. I made it through. I'm good. Okay? Pay attention. Make notes of it. Because when I asked a minute ago, only about 4 hands went up on very confident in where that 0 was. Okay? When you're looking at a fraction, if the 0's on the bottom, it's undefined. If the 0's on top, it's a 0. Okay, any questions there? How many remember that from algebra? It was about a year ago that you studied it. Okay. How many had me for algebra? Good. Well done. Way to be in my algebra. How many had Vogel for algebra? Way to be in Vogel's algebra. How many had Dvorak for algebra? How many had Hayashi? Way to be in Hayashi. How many had Axon? How many had Kerr? North Lakeans, all right. How many had Murphy? How many had Lee? Wickheiser. Way to be in Wickheiser sounds good. Who did I miss? Yoshi. Who had Yoshi? All right. Way to be in Yoshi's algebra. Okay. Just wondering. All right. Quick review. Let's talk about slope. So what is the equation for finding a slope of a line given 2 points? Okay, that was our next piece. Slope of a line given 2 points. Yeah.
M equals y2 minus y1 over x2 minus x1.
Very good. Right here. M equals y2 minus y1 over x2 minus x1. So if I'm given 2 coordinates to find the slope, I can use the slope formula. Okay? So with that, let's figure one out real quick. If you have the coordinate 4, 3, and let's make those negative just because we like negatives, and the coordinate -1, -6, I want you to find the slope of that using your slope formula. Ready to go? Okay, so when I do this, I like to put 4 spots. And I put those parentheses in those 4 spots. I put subtraction signs in between. And I'm going to label my points. I'm going to call this x1, y1, x2, y2. Now, how many labeled your points those? You use those as your 1s and 2s. How many went the other way? It should work no matter what. You should get the same thing. But if I put y2, y2 is -6. y1 is -3. x2 is -1. And x1 is -4. Now, the reason I put these little parentheses is so that when I get situations like this, where I have that double negative, a double negative becomes a positive. So I have -6 plus 3, which is -3. And I have a double negative there, which is a positive. -1 plus 4 is 3. And my slope is then? -1. Now, how many got -1 as your slope? Okay. Did anyone accidentally mess up the double negative thing? It's the most common mistake I see, so it looks like we're good on that. So why do we need to know slope? This is rise and run, right? When we're doing change in y, we're figuring out how far we go from one y coordinate to the other y coordinate, from y1 to y2. When we're figuring out change in x, we're figuring out how far we're going from one x coordinate to the other x coordinate. A lot of times we call that rise over run. Change in y over change in x, or rise over run. Now, how many remember dealing with rise over run? This would mean right here that for every point that I run over 1, I drop down 1. Or for every time I go down 1, I go over 1. Okay? That's what that rise and run means. So today, when we're dealing with slope, one of the reasons we use slope is so that we can use the formula y equals mx plus b. Remember, the slope-intercept form of an equation is y equals mx plus b, where m stands for, yeah, this is your slope. And b stands for? Y-intercept. Everyone tell your neighbor what a y-intercept is.
Where the line crosses when the line crosses the y-axis.
Okay, so it's where the line crosses the y-axis. Right there. That would be my y-intercept. So if I knew my equation had a y-intercept of, say, 1 and a slope of, say, 2/3, that would mean I'd rise 2, and then I'd run over 3. Oh, thank you. Okay, there's the y-intercept. So if I had a y-intercept of 1 and a slope of 2/3, so maybe I had y equals, thank you, 2/3 x plus 1, I'd be able to rise 2 and then run over 3, and I'd have my point. Okay, so we plot our y-intercept first. Some of you, when you first started studying this, you called this your starting point. How many of you called that your starting point? And now it's just our y-intercept. Okay, how many know how to raise your hand? Show me. Oh, good, some of you. Some of you don't. You have to, like, if your neighbor can't raise their hand, you may have to help them. Okay, if they only are able to get their elbow up and they stick their armpit in your face, just say, raise your hand, okay? The elbow and it's not. That could be considered offensive, especially if you forget something in the morning, like deodorant. Okay, so from here we rise 2 and run 3, okay? How many are with me? All right, well, let's practice that. I'm going to give you your assignment, and I want you to complete example 1 on your assignment. So I'll set this up here so you can kind of read through it while I'm handing it out. You're going to do the evens on the graph paper I gave you. Try to graph some of those. If I can make a quick comment about 2 problems, like starting on number 1 and 2. I know you didn't have to do number 1, so let's do, say, 1 and 4, all right? Or 2 and 4. So number 2, y equals 2/3 x plus 3. Now, I've had some students say that they've been taught in some of their classes. So all earbuds out right now. You're paying attention, right? That should be automatic. But I've had some students tell me in some of their classes, like, they changed 2/3 into 2/3 over 1. They actually write it like this. So they rise 2/3 and they run 1. Is anyone in here doing that? Okay, I just want to make sure we're clear we don't do that. Okay, so we start at 3, and from that point, we're rising 2. We rise that much, and we run that much. So we rise 2, and we run 3. And we always run to the right. At least I do. And 1, 2, 1, 2, 3. And 1, 2, 1, 2, 3. Now, once I actually see the trend, then I can go 1, 2 down, and I'll go to the left. Okay? But until I see that trend, I'm not going to the left ever. Okay? And then once I have it, I use a straight edge. So if you don't have a straight edge available to you, use a ruler, use the edge of a calculator, something. Some of you are amazing, and you can use the edge of paper pretty well. Okay? I don't want to brag, but I just use the edge of paper. Okay? So there we go. All right. I missed that point, though, so maybe I'm not that good. Okay? And then when you have, say, like number 4, y equals 3x plus 1/2, if they don't show a number under the 3, what is it? Yeah, this is a 1 then. So we rise 3, we run 1. Y-intercept's 1/2. Okay? We're going to spend about another minute on that section. I know that you may not finish it, but that's okay. Yeah? There's what now? You don't have to graph 15, right? What's our assignment? 50?
Number 50 you can't graph.
What are we talking about?
You don't even graph 50.
You guys got to read your directions, right? Your instructions. Read the instructions. High expectations, man. You guys, you only have to graph certain problems. Other ones you don't have to graph. Okay? So right now we're just doing example 1. Graph. These aren't, you're not graphing these down here, right? I hope not. Okay. So right now, you get about another minute or so of work time, and I'll emphasize one other piece, and then we're going to go on to parallel and perpendicular. Carson.
Yeah.
Carson's question is on number 12, would that be a 0 slope? It would be a 0 slope. Here's what I want you guys to take away, and I'd hope you had seen this in algebra at some point. If it's a y equals equation and there's not an x, it only is crossing the y-axis. And that tells you where it's crossing. You find 3 on y, and that line's going this way. Okay, it's going horizontally. If it said x equals only, then it would only cross the x-axis. Now, I know this isn't a problem, but if you were to graph x equals 2, you would have to find 2 on the x-axis, and that would be your graph. It only crosses x if there's only an x. If there's only a y, for instance, y equals 2, it's only going to cross the y-axis. If you look at an equation with an x and a y, for instance, this one we just did, then it has to cross both axes. Now, how many knew that? How many know it, but you didn't know you knew that? Okay, so everyone's clear. If it has only a y, it only crosses y. If it has only an x, it only crosses x. If it has an x and a y, it has to cross both. Okay, if you didn't make that connection in algebra, it's a good connection to have down. Okay, I want to move on. Okay, so you need to stop where you're at. I want you to go back to your notes, and I want you to talk with your groupies about this. And if you need a little help, you can look at page 85. It may help you out, but there we go. Parallel lines. What do we know about parallel lines and their slope? What do we know about the product of perpendicular lines and their slopes? And then you've got some theorems, 2.5 and 2.6, to kind of reference and take a look at. Okay? There we go. Check out that. I'm going to talk about this.
Oh, because the opposite.
Okay, parallel lines. Zach, can you help me? Parallel lines have what type of slope? Same slope. How many agree with Zach? Parallel lines have the same slope. It's very true. Okay. The product of slopes of perpendicular. Oh, real quick, picture of parallel lines if you didn't know. Right there. Notice their rise and run would be the same. We'd show this little marking to show that they're parallel. We put that little extra arrow in there. They're parallel. They have the same slope. M is equal. The product of the slopes. So if I multiply the two slopes together, Emily? It is equal to not 1. Not 1. It is a reciprocal. They're reciprocal. So if I knew one slope was 5, 6, the other slope would have to be negative 6/5. Okay, so what is the product of 5, 6, and negative 6/5? Negative 1, so you're really close. It's negative 1. Okay? If you were to multiply the two slopes together, you always get negative 1. Okay? They're reciprocals, but they're inverse reciprocals. So you have to change the sign and flip the fraction. Okay, so on the graphs that we've already completed today, I don't know where I have those. Set that over here. I did. All right. On say like this graph, and you don't have to do this on yours, but if I was looking at this graph, this had a slope of 2/3. I rose 2 and I ran 3. So if I wanted one that's perpendicular to 2/3 would actually be a slope of, well, let's flip it, 3/2, and then we'd have to change the sign. It's positive, we have to go to negative. So negative 3/2, I could even start at the same y-intercept and go down 3 and over 2. Okay, so if you're not sure, if you're doing it on the test, you're like, I think I'm doing it right. You could always just graph two lines and use the idea you're using for slope and see if that works out. Now, did I actually plot all those points right? Or when I'm talking and plotting points. Did I do that wrong? 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Okay. Thank you. It looked like something was going on there. All right, so I get perpendicular. They'd be right angles there. This point is wrong. Okay? Pretty cool. Here M is 2/3. Here M is negative 3/2. Okay, how many remember that from algebra? Okay, well let's check it out then. If I'm drawing a picture of those theorems, hopefully the theorems weren't too tough. Okay? Two lines parallel to a third are parallel to each other. So if line A is parallel to line B, okay, and line B is parallel to line C. So if I know this, A is parallel to B, and I know B is parallel to C, then I automatically know that since A and C are parallel to the same line, then that means what? Yeah, then that means A is parallel to C. So since that's parallel to that, and that's parallel to that, then those two have to be parallel. Okay, that's kind of one of those dust statements, right? That's theorem 2-5. Theorem 2-6 says in a plane, two lines perpendicular to a third are parallel to each other. So if I have a line, what do we want to call that line? A, because we're not creative like that. But what do we want to call this line? Perpendicular. R, way to be creative there. Okay? So we have line A perpendicular to line R. So A is perpendicular. There's our perpendicular symbol to R. We'll extend R there so it looks. A is perpendicular to R. Okay? And let's make another line. What are we going to call that one? M. Okay. M is perpendicular to A. Therefore, in a plane, two lines perpendicular to a third, which is A, so these are the two lines perpendicular to the third, are parallel. R is parallel to M. Why? Because they intersect both at right angles. Therefore, those two have to be parallel. R has to be parallel to M. Okay. Think we got it? Okay, well, let's see if you understand parallel and perpendicular. I want you to complete that. If the slope is 2/3, what's a slope that's parallel? What's one that's perpendicular? Go ahead and fill that out, please. Okay, let's check it out. A parallel to 2/3 is 2/3. Perpendicular or parallel to -7/5. -7/5. Parallel to 3. Parallel to -9. Parallel to 0. Parallel to undefined. Good. They're exactly the same, right? Okay, let's talk about cell phone etiquette. I figure you guys are in 8th or 9th grade. You can handle it. Earbuds out. How many people like having silly rules? The silly rules, like these are the ones I get from kids that I know. Like, dude, it's so stupid. We can't have cell phones in class. I mean, like, why can't we have cell phones? Duh. It's like, why can't we wear hats? Okay. Why? Why would I not want cell phones in here? Emily? They're a distraction. So if you can handle them not being a distraction, then it's no worries. However, I expect you to be responsible. I'm trying to teach you etiquette. Take out the earbuds when I talk. You cannot forget that. If that is a habit you're into when you talk to an adult, like if Eli or my daughter Lucy, if they're talking to me and they have their earbuds in, the first thing I do is pull that earbud out. Okay? I want to take scissors and snip them off. That's what I want to do. Okay? Take the earbud out. If you don't do that in everyday life, talking to friends and people, start doing it. It's called a habit that you're training yourself. If you're like, dude, I just forgot, McCoy. Come on, give me a break. I just forgot. You're like, you're talking, I just forgot. I always keep them in. That's the problem. Don't always keep them in. Take them out whenever you have a conversation. All right. Little lecture, sorry. I'll go back to teacher mode here. Okay. Perpendicular. Good. Switch it. -3/2. What's this one? Good. Yeah, it was negative. It becomes positive. 5/7. So it is positive. It becomes negative. And then, yeah, the fraction is 3/1. So this becomes 1/3. It was negative. It becomes positive. 1/9. What's perpendicular to 0?
Undefined.
And what's perpendicular to undefined?
0.
0. Right? 0 slope is this. Perpendicular to it is that. So 0, undefined. Okay? Same thing over here. Any questions there? All right. Okay. Your assignment is the even side. So on that sheet that I gave you, you're finishing up this. Now remember, you got to read through them. Find the slope of one that's perpendicular. For the given, determine if the corresponding lines are parallel, perpendicular, or neither. So this is the slope of one. This is the slope of the other. Are they parallel, perpendicular, neither? It's parallel, perpendicular, neither. It's a quick game. Mr. Vogel loves that game. Parallel, perpendicular, neither.
Wait.
Just P. Well, you can use symbols. You can use parallel. You can use perpendicular. Or you can use N for neither. Yes?
So we aren't graphing like 16, 32 on the side of that?
Question. Do we have to graph these?
No.
Good. It's good to ask a question. The answer is no. What would tell you had to graph them? Yeah, if it said graph. Right? All right. Cool. So no graph in those, yeah? Good luck. There's a